Okay, I wanted to provide you with some help on some of the Chapter 4 test review problems, some of the ones that tend to cause people the most trouble. For example, on this problem number 10, we're told to solve this matrix equation using an inverse matrix. So let's just review that process. The first thing, and by the way, I'm finding the inverse of this matrix that is being multiplied times x. X represents another unknown matrix that we're supposed to figure out. So the first step in finding the inverse is to find the determinant. And remember, when we find the determinant, think of multiplying we call these the A and the D numbers, so that's negative 24. And then we multiply what we call the B and the C numbers, and that would be 5. We always subtract, think determinant and difference. So the determinant is negative 29. Okay, so I know that this matrix does have an inverse, and so now to find the inverse, which is my next step, it's always 1 over the determinant, and then I'm going to multiply that fraction, negative 1/29, times a rearranged, changed matrix that I'm circling here. Remember, we switch places with these A and D numbers, and for the B and C numbers, we change their sign. So positive 5 will become negative 5, positive 1 will become negative 1. And now I'm multiplying, this is scalar multiplication, I'm going to multiply negative 1/29 times each of these four numbers, negative 8/29, positive 5/29, positive 1/29, positive 3/29. Okay, so this 2 by 2 matrix that we have just come up with is the inverse of this matrix. Now that you found the inverse, take the matrix that's on the right side of the equation, just bring it down and set up for multiplication. And just remember, it's very important that when you multiply the inverse times the matrix on the opposite side of the equation, you always put the inverse first. The order of these two matters. So inverse will, in other words, go to the left always. Okay, so now it's just matrix multiplication. And so remember, we multiply row times column. So I'm gonna write this out. And by the way, we already know what our product matrix should look like, because we have a 2 by 2 being multiplied times a 2 by 1. And so the inside numbers match, which means we can multiply. The outside numbers tell us the dimensions of the product matrix, so we're going to have a 2 row, 1 column answer. Okay, so for getting this top number, which represents row 1, column 1, just think about multiplying row 1 times column 1, really is the only column we have. So let's just write this out. Negative 8/29 times 29, and we add the product of 5/29 times 58. Looks kind of ugly, but really it's not, because if you think of 29 as 29 over 1, I know some people struggle a little bit with fractions, but remember how you can cancel this way, and those two 29s, 29 goes into itself one time, so those become 1s, and so really the product of these first two multiplied together is just negative 8. And we can do a similar deal over here. If we think of 58 as being 58 over 1, and we divide 29 into both of these numbers, then what we're left with is 5 times 2, which is 10, and negative 8 plus 10 is just positive 2. Okay, so we need to work on this bottom row, row 2, column 1, so let's use the numbers from row 2 times our only column, column 1. And so now we'll multiply 1/29 times 29 and then we'll add that to 3/29 times 58. Okay, well 1/29 times 29, of course, is just 1. And once again, I'll rearrange this a little bit. It's very similar to what we did on the this side. We can think of 58 as being 58 over 1. 29 divides into both of these numbers, so we can cancel. So 3 times 2 is 6. So 1 plus 6 is 7, and that is our bottom number. So the answer for x is equal to this matrix here. So in other words, if we had taken this original 2 by 2 matrix, multiplied it by this matrix, the result should have been the matrix on the right. And it's a great idea to check that on your test if you have time. All right. This is a similar problem, but it's got an additional step. The first thing that has to happen is we need to subtract this matrix from this matrix. So let's go ahead and set this up. So just match up the elements. 6 minus 2 is 4. 2 minus 7, negative 5. Negative 2 minus negative 3, so be careful there, you're subtracting a negative number. So negative 2 minus negative 3 is just 1, and 3 minus 4 is negative 1. Okay, well at this point we have a very similar problem to what we just did. We're going to find the inverse of this matrix being multiplied times x, which means we first find the determinant. 4 times 2 is 8, minus 1 times 7, which is 7. The determinant is 1, so we know an inverse exists. So here's how we find it. 1 divided by the determinant. And now remember, we're going to change this up a little bit. We're going to switch places with the 2 and the 4, and we're going to change the signs of the other two numbers. And since we're multiplying by 1, it makes finding the inverse very easy. So here is the inverse, and that inverse needs to be multiplied times the matrix on the right side of the equation after we subtracted. So be careful that you don't go all the way back to the beginning. It's the matrix that represents the difference between these two. Right? Okay. And now it's just matrix multiplication, which hopefully by now you're very used to. We should end up with a 2 by 2 product matrix. So let's see if we can get to this answer pretty easily. We have 2 times 4, which is 8, plus negative 7 times 1, which is negative 7. So 8 plus negative 7 is 1. All right, now let's work on row 1, column 2. So that's going to be 2 times negative 5, which is negative 10, plus negative 7 times negative 1, which is 7, and that's negative 3. All right, so let's move along. We're going to work on row 2, column 1. So that's going to be negative 1 times 4. Negative 4, plus 4 times 1, which is positive 4. Of course, that's 0. And I'm getting a lot of colors here, but hopefully you can follow what I'm doing. Maybe I'll just change back to red. Row 2, column 2. So negative 1 times negative 5, which is positive 5, plus 4 times negative 1, which is negative 4, and that equals 1. So this is my solution for x. X is this 2 by 2 matrix, 1, negative 3, 0, 1. Okay, so that takes care of the solving matrix equations by using an inverse, and so I will kind of break this video up into different types of problems just so that you can maybe just focus on the videos that you need the most help with. So This should help you with numbers 10 and 11 on the Chapter 4 test review sheet.